what you're looking at here is the circuit schematic for the 12 volt DC operated microwave relay circuit. So what you do is press that button there, and you've got the NE555 timer, that's the high power timer, LED 1K resistor, a diode, a BC547 transistor, and a 1K resistor. That's the circuit for the relay circuit here. Now I'm going to show you something here. Right. Okay, this one's all been dolled up here. The aluminium tape over it, and I've taken the big long wood pieces out there to hold the cable down out and put a thin board there instead. So that's all done and I'm in there. Over here, I've been working on the second one here. This transformer looks a bit on the smaller side, but the input resistance for the primary coil is 3.0 ohms. That's the highest resistance I've ever had yet. And I've got these sitting on these aluminium pipes here. That's these things here. You put a strip of metal through that and you can anchor it to the wooden base here to keep it still. The idea of those pipes here is elevate the transformer, give it more ventilation there. Okay, now I've got the microwave up in 12 volt relays inserted into a PVC thing that I made last night. Okay, and the fans here, which I've got to wire it up yet anyhow. Right, now this wire here, unlike the other one over here, is 12 gauge. The other one's 10 gauge. This is 12 gauge wire. And of course it's 12 gauge wire. I was able to get about 6 turns in there, so luckily, hopefully I'll get a bit enough more voltage to be able to use it for a bridge rectifier without too much voltage loss. Right, now this is the input for the DC 12 volt operated relay circuit board. Now you're probably wondering how you're going to get that through a piece of 3-ply wood when I put the panels on. Well, I use one of these wood boring bits to slightly countersink the hole so it's thin enough for these to go through. And then you can put the screw on the outside there. Okay, so that's it there. The second, the low voltage high current power supply. Now of course I'm using a 12 amp wire, which is a tiny bit thinner than that one over there. Maybe have a couple more strands in it, but anyhow, that's how that goes. Now all I have to do is anchor that down with strips of metal. You put the strips of metal through there, put screw holes on the end and just screw it down to the board. So that thing's elevated. Now this transformer, I recently got it welded, professionally welded, and so that's welded together there. The wires are sticking up at the front. You've got to be careful. If that wire breaks off, the whole thing's buggered. So I've got to solder some other wires to that one there. So all I have to do now is wire it up, then put the panels on, 3-ply panel, countersink the hole just enough for one of these to get the threads of that through. It's got to be the same thickness as plastic. You know, like you can get these through the hole in the plastic circuit box. They're only thin, so you know. So that's it. Power supply number 2. That's the last one I'm building too. As for the output here, I'm going to put extended cables on that, and I'm going to put jumper leads on instead, so I can use that for experimenting or anything else in that. Okay, thank you for watching my latest update.